Okay, so good morning. I'm Aadit, and I'll be presenting on the Introduction to Python workshop. Uh, This logo here is a trademark of the Python Software Foundation, and so yeah, I just thought I'd mention that. Okay, so let's start things off by talking about the history of Python a little bit. So Python was developed by Guido von Rossum in 1989. And it started off as a hobby programming project to keep him occupied during the weeks of Christmas when his office was closed. Python is heavily influenced by the ABC programming language, but because that's the language that was used at the research institute where Guido von Rossum was working, but it is written with Unix and C programmers in mind. Now let's talk about some of the features that Python offers. Um, Python is a dynamically typed programming language, which means that the types are assigned to the objects during runtime, unlike in statically typed programming languages, where these types are specified in advance, um, so that the compiler can know what types the objects are. Um, and secondly, Python is an interpreted language and not a compiled language. An interpreter basically steps through each line of code one by one and interrupts the program once an error is encountered. A compiler, on the other hand, generates all the errors of the program at once by going through the whole program. Python is and can be used as a scripting language, which means that you can just write a bunch of statements to automate simple tasks. But in a real world project, what you basically do is you make functions and classes and organize them into different modules so that you can build more complex programs. Um, Another nice thing about Python is that it can be also used to implement object-oriented programming paradigms like encapsulation, polymorphism, and inheritance. But the caveat is that the OOP is considered pseudo because you're still able to modify the fields of an object. There's no concept of access specifiers, which can be seen in OOP languages like Java, where you have public methods and fields that are accessible to outside classes, protected classes and fields that are accessible to inheriting classes, and private fields and functions that are accessible only to the inner class or the class itself. As with any tool, Python has its pros and cons, and it's important to know these trade-offs so that you can see why you'd like to go ahead with Python, or if you do not want to use Python, why is that the case? Um, so the pros of Python, the first one is that you don't have to learn complicated syntax like in many other programming languages. And that makes it really good for prototyping, which means that you can design small programs or small mockup software in Python to demonstrate a proof of concept. Um, uh, People will often describe writing Python code as writing pseudocode. What this essentially means is that you can take any you can design pseudocode for your algorithms and then translate that into working code in Python almost very quickly. Um, on the other hand, Python programs are slower to run because they are interpreted as opposed to compiled, which I've mentioned earlier. Also, due to dynamic typing, you may end up performing some unintended modifications. By this, what I mean is that you can, for example, have a variable that you intended to be an integer type, and that's how it was initialized first. But then you end up initializing it with a string, for example, and that uh, causes some operations to fail along the way. Um, in a compile language, or a statically typed language, actually, you would have the compiler throw an error in advance. But during e- for an interpreted program like in Python, what would end up happening is that you're basically just trying to hunt for where you might have made that state modification. Yeah. And you also need to, sorry for that. Yeah. Often you have to also investigate further on why your implementation might be suboptimal, because there might be some hidden complexity for certain operations. For example, you might use a list comprehension without understanding that like certain operations take on time and so on. Um, like the list comprehension itself, like iterating through a list is takes on time, and then that affects your algorithm type complexity. Um, so when it comes to writing any real world software project, you'd end up using libraries. And libraries are essentially independent software components that help you achieve different tasks within a programming language. Um, so if you're using Python, then it comes with its own set of libraries, which are known as the Python standard libraries. And you can go to the Python documentation website and have a look at how you can use those. You generally don't have to worry about implementation, because these are meant to be black box solutions. You can dive into these if you are interested. And sometimes you do some drilling down of the problem that you may be facing. Yeah. Um, in addition to the libraries offered by the Python language, you often have to also use third-party libraries which are not in the language. Um, and those are developed as extension by other developers. You can install third-party libraries using either pip or previously using easy install, but now you mostly end up using pip because easy install is now deprecated. And the some of the examples for third-party libraries include TensorFlow, Keras, and scikit-learn. TensorFlow and Keras are more catered towards deep learning applications, while scikit-learn pro provides algorithms for the more traditional kind of machine learning related applications. Now let's talk about the building blocks of simple Python programs, actually even more complex ones. Uh, So the first one would be statements. Then we move on to operators, functions. Then we talk about some of the basic data structures. Finally, we'll talk about classes and objects, which are essential for implementing these data structures. And finally, we'll talk about typing, which is more of an addendum because it's only been introduced from Python 3.8 onwards. So what are statements? Statements are individual lines of code or blocks that serve as one unit. Um, what are the types of statements you're likely to encounter? The first type are expressions, including arithmetic or logical expressions. We'll come to know more about these kind of expressions as we discuss them in our slide on operators. Another type of statement that you're very likely to encounter is an assignment statement, because that's what you use to assign a value to any variable. Then you have your branch selection statements like if, else, and else if, which is abridged to elif in the Python language. You have your loops for, while, and finally you have a return statement which is used in functions, and this has the keyword return appearing in the beginning of the statement. Okay, so now we'll talk about operators. Operators are generally used to carry out calculations that involve objects of the same data type. Um, these are the kinds you would encounter in mathematics as well. And in Python, how these operators are implemented is that they are acting as wrappers, which are used by internal object methods. So think of this. Let's say we are adding two numbers. So these numbers are of let's say like integer data type, and so they are implemented using the integer class. And when you're adding one number to the other, basically what you're doing is you're internally calling one of the methods on the integer object. In this case, it would be something like an add method. What are the types of operators you would generally encounter? You can think of them in terms of unary or binary operators. So unary operators, some examples include the increment and the decrement operators. And what these do is basically increment is used to add a certain value to a variable, and decrement is used to subtract a value from a variable. And the types of the types of binary operators you'd see are arithmetic and logical, which we discussed previously in our uh, about binary expressions. And so like arithmetic operators are plus, minus, divide, modulus, and times, for example, and these are the same as you'd see in mathematics. Whereas logical include and, or not, and these are used for dealing with Boolean values, which are basically true and false values. Now let's talk about functions. Functions are essentially blocks of statement that can be combined into one unit. And functions come in handy when you want to reduce redundancy and reduce complexity. So when you are encountering um, like certain lines of code that are repeated over and over again, or you have like hundreds of lines of code, which is complex to reason about, then in both kind of cases, you should think about using functions to simplify your task. And the few functions and specifically pure functions are similar to mathematical functions. They function as input and output machines. Um, so they take in a set of inputs and give you an output in return. The distinction here between pure and impure functions is that pure functions do not have any side effects. They basically take in the inputs and do some processing to return the output, whereas impure functions often end up modifying some of the states of the parameters. Um, the nice thing about functions is that you can use them to call other functions or even themselves. And the later property is known as recursion. An example is the Fibonacci function over here. The two things that you must take note when you are implementing recursive functions is first that the state of the parameter must change, and second, the base cases must be called so that the recursion ends at one point. If you miss either of these, then you would end up with a situation known as infinite recursion. So for example, in the Fibonacci function, if you were to miss this first lines of code, or um, add a Fibonacci n somewhere in the return statement, then you would end up with a like infinite recursion situation. And that's because we want to solve like smaller sub problems. You want to split the big problem into the smaller sub problems and solve them until there's some point at which you already know the solution to the problem. That's a common characteristic of recursive functions. Now, let's move on to talk about tuples. Tuples are immutable data structures that can hold on to multiple values in order, which means that the order in which the elements appear is very important. For example, in this case, this is a tuple consisting of the first element as 3 and the second element as 4. If you switch around these elements, so another tuple would say 4 comma 3, then that's a different tuple. Since Python is dynamically typed, you can have heterogeneous tuples, which means that the tuples can be have values of different data types. As you can see over here, the first two values are integers, but the last one is a string. This is something which is different from like statically typed languages, where you generally have to have uh, like containers like lists and tuples having values of the same data type. Tuples are themselves implemented as data type using the tuple class. And tuples can be created using either the tuple inbuilt function or round brackets, as you can see over here, where the values are separated by a comma in between. You also have another way to generate tuples is by taking, say, a list or a set or any other object and applying the tuple constructor on it. Um, and yeah, the many of these methods that you see applied on tuples, like in to check whether a particular element is a member of the tuple, or trying to access a value in a tuple using an index. All these operations are implemented as common methods required by an abstract parent class. And this parent class is known as the collections.abc.sequence class. Uh, of course, you can check this detail in the Python documentation website. It's just more for informational purposes. Next, I'll be talking about lists. Unlike tuples, lists are mutable data structures which hold on to values in order. So the main difference here being that you can modify the values in a list. And again, like in the case of tuples, you can have heterogeneous lists as well. Lists are also implemented as a data type using the list class, and similar to tuples, you can create them using a list constructor, or using an angle brackets instead of the round brackets, with the values in between separated by a comma. Again, like the common methods which are implemented for lists, which is quite similar to what you see for tuples, are as per the requirements of the abstract parent class collections.abc.sequence. Now let's move on to sets. Sets are different from lists in the sense that even though they're mutable, they can hold on to multiple unique values, and these do not have to be in a particular order. Actually, they are not in any particular order. So like if you have any duplicate values in that you want to hold in a set, in when the set itself is processed, it would be in the end holding on to only unique values. And since these values are not in any particular order, you cannot access them using an index like you can in lists or tuples. Similar to tuples and lists in Python, you can have heterogeneous sets, and the properties of sets, as you'd see in the Python language, are similar to the ones you'd encounter in mathematics, where you have operations like union, intersection, and symmetric difference. Um, and again, sets are implemented as data type using the set class and can be created using either the set constructor or using curly brackets. In this case, the abstract parent class is a mutable set, and so the methods implemented are slightly different, though you have common ones such as testing for membership of an element in the set. Um, Now let's talk about dictionaries. Dictionaries are also mutable data structures, but they consist of key and value pairs. The important thing to take note is that the keys themselves must be immutable. So you can't have something like a list being a key, while the values can be of any data type. The keys and values do not necessarily have to be of the same data type, and can be of different data types. For example, over here, you'd see a string mapped to a list. And dictionaries are implemented as data type using the dict class, and can be created using either the dict constructor or curly brackets, where each key value pair is separated by a comma. In this case, the methods you'd see implemented for dictionary class are as required by the mutable mapping abstract parent class. Now let's talk about strings. Strings are immutable collection of characters. So they share the same immutability property as the tuples. And when you want to add say characters to a string, or like take a substring of a particular string, you are essentially creating a new string because it's immutable. Strings are implemented as a data type using the str class, and the methods implemented as required by the parent class, which is collections.abc.sequence. This is similar to tuples and lists. And now I'll talk about ranges. So the range object is different from the other kinds of data structures we've talked about, and they usually represent a collection of values for a arithmetic progression. So if you don't know about arithmetic progression, so as a quick refresher, basically an arithmetic progression is a sequence of values with a common step difference in between them. So the set of natural numbers, the set of whole numbers, and integers, all those are arithmetic progressions with the step difference between the successive values being one. But with range objects, you can specify any kind of step difference to represent a generic arithmetic progression. Ranges come in very handy when you want to iterate over a set of predefined values, like say you want to iterate over a list, then you can use the range object for creating the index which you can use to iterate over the list. Ranges are defined by the start, stop, and step parameters. Um, so the start parameter is basically to define what is the starting value of the arithmetic progression, and stop is the end value. Because in the case of a programming language, you wouldn't be able to represent uh, generally a set of infinite values. And the step parameter is used for specifying the step difference between successive values. Okay. Um, Now I'll discuss about classes and objects. So for the range object, the range data structure which I mentioned earlier, a possible implementation for this using the range class is as shown over here. Um, Classes and objects are basically the internal tools that are used for implementing the OOP paradigms. Um, and Classes represent the blueprints, while objects are instantiations of the class that are formed by specifying certain values for the inner fields and so on. So like in this case, like the class range itself gives a template or a blueprint for how any range object should be instantiated. And you basically instantiate a range object by specifying the concrete values to the constructor method. Yeah, so in this case, the range variable is holding on to a range object, whereas the range class itself uh, forms a template for the range object. Um, yeah. So basically, classes also consist of methods and objects that are instantiated using the init constructor method. Lastly, I would like to talk about the typing. And basically, this is a feature which is introduced in the Python language since the 3.8 version. What this essentially allows programmers to do is to specify the types for variables in Python. And this helps avoiding certain kinds of programming errors that you'd likely encounter because it gives you better clarity about what are the data types involved using type hints. But the important thing about this is that typing has not been mandated in the language because Python is essentially still a dynamically typed language. So this is the end of the presentation, and I'd like to end off by um, highlighting some of the reference materials that you can use to learn more about Python after this workshop. Um, So the Python documentation website is a very handy resource for looking up specific language specific features. Um, Real Python comes in quite handy for tutorials and for articles on topics which are very specific to Python development on a regular basis. And Python Tutor is quite great for visualizing Python programs. So that's all I have for this presentation. Thank you.